Okay, everyone, welcome back. This is Brazil 2021 problem 3. Um, you want to you have irrational alpha greater than 1 such that alpha to the n is k less than a square. I Huh. Yeah, it's about time I did this one. Holy shoot. Um So the thing that bothers me is that, like, oh god, I don't know I have no idea what the answer is. Such alpha exists. It is possible to set this up. And like the general idea behind if you want to set something like this up, let's give an example, alright? Suppose I take like 3 plus root 5 to the n. Then this, if you add it to 3 minus root 5 to the n. So this number is an integer because the root 5 parts cancel out. And if I denote it by xn, this xn satisfies some recursion. I just made up, I think this example was like an normal I did in my last year of high school. That's why I picked 3 plus root 5. But this xn will satisfy some linear recurrence. So fine, linear recurrence, okay. I have no idea what the initial values are. I guess they're like 6. Well, okay, the initial values are, oh my god. Holy crap. X1 equals 6, x2 equals 28, and then xn plus 2 is like... Okay, so this characteristic polynomial is like 6 and 4. So you can actually find specific values of alpha for which you have really good control over floor alpha to the n. And the issue is that linear recurrences can always output squares. I'm afraid I'm gonna eat my words. But linear recurrences could always output squares. Is that true? That's true. And here's how you can do it. Actually, let me give you an example of an alpha that works, alright? So this is like a random linear recurrence I cooked up. You know, whatever. I'm just cooking, okay? Let's consider let's consider xn squared. I'm not even going to define a name for it. So this one is 9 plus 6 root 5. And then whatever the inner, like this is 8. 9 minus 6 root 5. And so now we have our first prototype. 9 plus 6 root 5 to the n for all sufficiently large n will be like xn squared minus 8. And this is just true. Which is terrifying. Because I just made up crap and I got a construction for k equals 8. And you can imagine in general this will do... I can build a lot of things this way, I think. Like, I feel like I should just be able to build a lot of examples of this shape. So, in general, if I generalize this as much as I can, what's the procedure? If I have, that seems wrong. Did I fuck up? What did I mess up? 9. Sorry, not 9, not 9. 14. But the thing is, the problem doesn't care what the value of alpha is, right? It cares that I have like some value. Okay, also just for completeness, x0 is like 2. So in general, suppose I have irrational numbers like they monopolized alpha. I would have used alpha and beta, but alpha is already in the problem statement. No, my Greek letters! What does these are as? Such that x, t, this is an integer quadratic. Then we can construct an r greater than 1 greater than s. So then I can construct the sequence xn is equal to r to the n plus s to the n, which is an integer sequence, and then xn squared minus... Wait, shit, am I stupid? Sorry, this is an a to the n, not... Oh, Shiba. Never mind. No, ignore what I just said. Freak. Okay, never mind. So if I want this idea to work, I actually need specifically... I need the product to be 1, right? If I want to... Okay, so I can construct t equals 2. Fine. So, okay, here. We're gonna just cut everything in half, alright? Oh, shit. Oh, I was hoping that this would give me a strategy that would let me... Whatever, it doesn't matter. Okay, so now instead of a to the n is wrong. This is just 2. So, okay, is this fine now? This is... k equals 2 works, right? I hope. Can someone check that I'm not screwing this up? 2 times 4 to the n, yeah. Yeah. So if I want product 1 specifically... I see, okay. Oh, sheep. Okay, sorry, my bad. 3. Wait, k equals 3 is the only one that works? Okay, that's a very big spoiler. But also, seriously? It's not that big of a spoiler. Wait, what? I mean, okay, maybe it's not that. I don't know. This is greater than 0. Anyways, okay. Really? 3? Anyways, okay. Anyway, here's the random construction I came up with, alright? It's a construction. Okay. That's so scary, though. Cause I mean... I need to somehow force this to be the only kind of construction. What? Wait, how am I gonna show? I was really hoping I could just construct every k. Because then I'm like, okay, then I have a plan. But But if you want to show that a value of k can't work, well, that's gonna be interesting. Because you don't even know, like, alpha is a real number. Like, you don't even know it. Like, maybe I would believe you if you told me, it's like an algebraic number, so you can write the other Galois conjugates and, like, pray, even though most of the Galois conjugates might not be less than 1. But, okay. If it's like a random real number, now... Really? How are you gonna do this? Like, okay, if it's a random real number, I have to use inequalities of some shape now, right? Like, you cannot use just number theoretic methods because alpha... Like, real numbers are too big. It's not that bad? I don't believe you. This seems pretty bad. Okay. Anyways, let's say like alpha to the n is... I have to write inequalities now, because alpha could be real, and if alpha doesn't have Galois conjugates over q, like none of my integer polynomial stuff has any chance of working. So anyways, the sequence of numbers such that this is like true. Okay, they're irrational, so I can... Like, I guess this is a true fact. And like what? Like... like how am I gonna extract k equals 3 though? Like, I don't... Heck, what on earth? I'm gonna change the statement to say floor alpha. Feels weird seeing minus written out in text. Like, something special has to happen when k equals 3. But I can't imagine what that would be. So I have these like size... I don't know, man. Do I take logs? That seems pretty bad. So, okay, I have this alpha, it's like... Oh no, it's awful. Actually, maybe, okay. Maybe I can just use the inequalities I get? I don't see an endgame, but I don't have options, I feel like. Like, there's like very few things seem like they will feasibly do anything. So, let's imagine I have like x here, alright? And then, you know, lo and behold. And alpha is the thing that we don't have any control over. So, I mean, I guess what I do is I write like I get two inequalities out of this, right? Like, one of them says y squared minus k is less than alpha x squared minus k plus 1, and then the other one says the other thing, but... No, I flipped it. Sorry. Alpha is on this side on the other one. And what I'm gonna... Like, I think So what I'm gunning for is well, okay. Well, I guess what I'm trying to do is divide and get alpha between sandwich between two things. So I need to make sure I don't mess up all the signs, but I think this implies y squared minus k, x squared minus k plus 1 over here, and then x squared minus k, y squared minus k plus 1. And I want, it's like this Pell-like equation that is supposed to have infinitely many solutions. I hope. Maybe. Pray? I think something's wrong. I feel like I flipped something. Something's flipped. Shiba, 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 shiba. Y is on, sorry, Y is on the other side here. Okay, great. Now what? We cross multiply and pray? I think it's just, this identity is always true though, right? Is it? I can't tell by looking actually. I'm just gonna cross multiply and pray because I literally don't have any ideas. This is just true, right? I don't think this buys anything, like, at all. Hey, welcome to the stream. If you don't know who I am, I'm Evan. I coach like high school math contests. And this is a thing where every Friday my kids throw problems at me and I try to solve them with varying amounts of success. Yeah, so this identity is just true. Like, as x squared minus k and y squared minus k are both positive, so it's like this is not going to do anything. But I don't... Solving your book for IOQM. Which contest is IOQM? Oh. I see. It's India's team selection. Okay. Okay. Yeah. Like, how am I gonna get through? Like... Alright, good luck. Like, what am I supposed to do with this? As an equality using what? Remainders? That doesn't make sense. Okay, so if I take like a square root of alpha, like somehow I can take a square root of alpha and it's like not losing any information. So then it's just a thing of like, I mean, yeah, I don't really have a choice. Like, there's. All right, we're gonna delete all this stuff. Okay, so I'm gonna just use like alpha to the 2n. All right, I'm just gonna only look at the even indices so that I can, because I don't think it makes. Well, it's equivalent, and I'm just trying to show k has to be 3. So we're gonna write it this way. This way, like, you know, we think x sub n is about alpha to the 2n. And then there's like a remainder Rn. Actually, we'll call it epsilon n. The point is epsilon n is between 0 and 1. And like, now what? Like, okay. Yes, my typing speed is one of the things I do better than other people. No, I'm not like as fast as some of the people who play typewriter and stuff, but I'm a lot faster than average people. That is true. Now play around with this equation. That's not helping. Oh, actually, hang on. Alpha. Are you telling me I'm going to try to take a difference of squares, and then each of these is also like... I'm about like 150-ish, I think. I'm not 100%. It's been a while since I've measured it. But, Okay, actually, I can get behind this. So, alpha to the n minus x sub n. Okay, this is clearly some big positive number. This is some number that is, not very big. Like, this is big. And then alpha to the n was, like, close to a square. Wow, okay, I'm really glad I used 2n now. This number was close to a perfect square, right? Like, alpha to the n was supposed to be... From which country? I mean... I go to school at Mass Tech, so you can probably work out which country I'm in from there. Okay, actually, yeah, this difference of square size constraint is actually really good. Can I iterate this? I feel like I should be able to iterate this. Like, if I have an alpha... Okay. Okay, here's what we're gonna do, alright? So, like, alpha to the n was, like, whatever... Like, fix a particular index. Like, and there's some integer, like... Here, we'll... Thank you, Firemaster U, for the follow. I'm just going to write it up to 8 just so that I can see what's going on. This is like alpha to the 8n. Oh, no, sorry. Squares only go... Okay, I can't keep doing this because the squares only go up one step. Thank you, I'm interested in math for the follow as well. Okay, anyways, yeah, this thing is like big, right? Like, this is really big. And alpha to the n minus x sub n. So we knew alpha to the n is like... I see. The fact that it's a square is giving me a difference of squares, and that's why I can pin something hard. So alpha to the n. I'm trying to imagine. Okay, in the example we know, we think k is 3, right? K equals 3 is the value that we decided is. We think is the only possible one. So this thing is like. In reality, this number is pretty close to. I don't see how k equals 3 is going to pop out of this. I agree this feels like it should be what I'm doing. Because now we have some control over this. Because we know alpha to the n was like... Here. Okay, well, I changed my mind. We're going to bring in... We're going to use the indices the way that they were meant to be used. So we're actually going to go back to using 2n here. And the point is that we also know that alpha to the n is xn squared minus k plus some epsilon. So this implies it's like xn squared minus x2n minus k plus epsilon n times alpha to something here which is like really, really big, because alpha to the n grows exponentially large and it's literally exponential. It's equal to epsilon 2n minus k. So this thing is like huge. And what that kind of... This is almost what I want, actually. It's like, now you know xn squared is... Okay, we're gonna... Okay, just take n big enough, right? I guess the point is xn squared is like... I don't even know how to write this. Just like O of alpha to the minus n. Like this thing is tiny. It barely is anything. And this is an integer sequence. Epsilon n. Okay, so right. So yeah, at this point, like, I guess the point is, okay, xn squared. Okay, the other thing is between 0 and 1. So for large enough n, xn squared is like xn 2k minus k plus something which is like at most... Epsilons are positive, right? So epsilon n is positive. And the other thing is like... It's like between 0 and 1, it's positive. This thing is some negative offset. I'm writing an integer thing. This is equal to epsilon n. I think the important thing is that the signs are... Okay, so like, it's the difference of two things which are... This is between 0 and 1 strictly. This is also between 0 and 1 strictly. So this has to actually be like totally sharp. like this has to equal 0 because it's an integer. It's strictly greater than -1. It's strictly less than 1. Where'd the -1 come from? Did I flip something? Shit, it's minus here. Never mind. Okay, but the sum of two... Yeah, okay, it's same logic. The right-hand side is an integer between 0, -2, and 0, strictly. So it's -1. In other words, for large enough n, we have the relation xn squared equals x2n plus k minus 1. And even with no alpha, I have a hard time believing this would happen for almost all k. No, actually, sorry, that's a lie. The indices are fine. But I can sort of like unwind this. Right, like I can... If I go back to the... we're gonna let f of s... Well, let's let f of t equal t squared minus k minus 1. Alright, and basically we're trying to gun... Whatever. Then... like floor alpha to the... Like let's take some offsets so that we don't run into too small issues. Equals f applied so x is where the sequence of... Oh, Shiba. I need to be a little careful. X to the m times 2 to the n. I should use different parameter names. Whatever, it's... do I want to reuse n? We'll use e for the exponent. You iterate this a ton of times. This x sub m squared minus k plus some epsilon m to the e. But we also have this recursion, so this is equal to f of f applied a bunch of times to xm. Minus k plus epsilon m times 2 to the e. Squared. And we know x sub m is about well, I mean, I'll write it in explicitly, right? Like this is square root of alpha to the m plus k minus epsilon m. Maybe I don't even need... Do I want to iterate it a bunch of times, right? So that the integerness like stacks or something. I guess the question is like, how do you iterate this function a bunch of times? So I know how to iterate like t squared minus 2-ish kind of thing, but So I should know how to iterate it for So t squared minus 2 is like a little special somehow. Because you can do like this 1 plus 1 over u thing. And then when you iterate it, that function kind of actually stays under control. Whereas if you iterate, like... Yeah, the difference of square things is where we're getting leverage here. And then somehow... Okay, yeah. Man, how do you come up with problems like this? Can't imagine. So... I feel like... Wait, I feel like I messed something up. But yeah, the size should orbit, like the size should go out of control or something. If you keep having these offsets somehow. Should I be using the fact that... So, like, in addition, we also know that this is, like, all the epsilons are going to be really close to... This is like epsilon 2n, right? Like, in addition to knowing the recursion for the xk's, we also do know something about the epsilons, which is that they're all really close to 1. Are they really close to 1? Yeah, all the epsilons have to be really close to 1, so I don't... You can get explicit. Yeah, yeah. It's like epsilons are super close to 1, so it's kind of like, yeah. I don't know, man. Is foundation a typo for foundation or bounding? For Twitch chat. Yeah, the problem, like I'm staring at this being annoyed because when k minus 1 equals 2, I actually know how to like loop the function, but like for any other value, like I can do k equals 1. Like when k equals 1, I can see that this is not going to be true, because then f of t is, yeah. But like, how do you iterate t squared minus 1? Is that a thing you can do? If I make a like the basic premise is I want to make a substitution. I should know how to do this. I know how to iterate t squared. I know how to iterate t squared minus 2. Can I iterate? Actually, even the 2 case is pretty. T squared minus 2 is not great. Like, I guess it's not easy to write explicit. Can I go? No. Wait, is this like the recursion in the Mandelbrot set? No, it suddenly occurred to me. I feel like I've. Hang on. Is that why I can't characterize it? Ah, it's the Mandelbrot. We're looking at the real part of the Mandelbrot set. Okay, that's beautiful. Okay, that means that I'm deluding myself if I think I can iterate any value. Okay, -1. Yeah, there's no close form in that case. Because the Mandelbrot side is complicated. Okay. Man, it's so tempting because I know exactly how to do k equals, like k-1 equals 0 and k-1 equals 2. Okay, fine. Never mind that. What do I do now? What if I just take this thing and stick it back in here? Does that kill k, actually? I think that kills k, right? Okay, we're gonna drop the iteration idea because I don't want to do dynamic system crap. Now, okay, alpha to the n is actually equal to x to n plus -1 minus epsilon n. Okay, putting this back in. Okay. I mean, sure. So I mean, I've done reindexing. So like the x's are. Okay, I feel like I need to jump back a layer, right? Like if I take this and replace everything with 2, it's like 2. No, wait, what am I doing? Hang on, I suddenly got confused again. Like, so I have x sub 2n is really close to... Wait, what the hell? Wait, I feel like... Hang on. Why is this giving me information? This feels like it shouldn't give me information. Yeah, this doesn't... Yeah... I do like this, the fact that this version doesn't have a k in it. Like now I have a sequence of integers. Well, I want to use the fact that it's like... Okay, how about this? I'm gonna square this, alright? Alpha to the 2n is then equal to x2n minus 1 squared minus... And on the other hand... On the other hand, we know that it's supposed to be like k less... Oh, but the problem is this can be pretty big, right? I think? I feel like I just ran myself into a loop. Well, okay, the upshot is that this doesn't have an epsilon 2n in it, or a k in it. So, I don't know. I feel like I'm just getting, like, this thing is equal to 1 in some really convoluted way. But this feels closer. Like, it's like... We think the epsilons are all pretty close to 1. That's the thing. Yeah, actually, epsilons are really, really close to 1. So this ought to... I should write it that way, I guess. So... Right, okay, here. So epsilon n is minus, so it's like 1 minus also for large enough n we now have, okay, so plus, okay, so we're going to write this as minus epsilon n, minus epsilon n. Minus 2, 1 minus epsilon n. Yeah, I think this equation felt really good because it's like, oh wow, I have a alpha to the n is, you know, something. Anyways, yeah. So, sorry, I somehow put the minus 2 in subscripts. But yeah, the claim is that this thing is tiny, right? Like this thing is some very small positive number, which is in the interval like is this bound good enough? Do I need a better bound? I might need to be a little less crude about this. I mean, okay, you want me to just throw this at that and then... I feel like I need like pretty tight... Like the point is this thing is really, really close to 1. I mean, okay, I guess the end game is that this thing might be pretty close to like if I just set these equal, do I get anything? I get like some stuff with okay. This is gonna be rough. All right, we're just gonna dive in. Epsilons are numbers between 0 and 1 that they're the fractional parts when you take the floor of alpha to the n. So they're defined in this line here. Oh lord. So the point is that this is epsilon to n. Okay, so we're gonna just cancel the crap that shows up and oh my lord. So on the one hand I have like minus 4 x2n plus 4 minus 2 1 minus epsilon n. Okay, why don't I just substitute in the thing instead of trying to guess at it? So we're going to get rid of all the epsilon n's by doing this substitution. Plus... Because 1 minus epsilon n is something really, really small, and we're going to write it that way. Okay, so the equation I get is this monstrosity. This doesn't feel very... I want to get rid of the x sub 2n as well. So that everything is in terms of... Well, okay, actually, maybe... This I don't feel like I did this very well. Why is it not... Wait, what did I do? K minus 1... What? The x sub 2n is still causing me a problem. Where's minus 3? There's a minus 3? In left. Wait, I don't... Oh, here. This thing. Yeah, so this is a small positive number. So when I take the floor... It's like... Yeah, when you take the floor, you round down. Like, if I have an integer t, and then I'm taking the floor of t minus 2.01, that floor is t minus 3. Lord, oh my god. Holy shit. Wait, I feel like this isn't good. X sub 2n is actually a lot bigger than x sub n, right? No? Is it? No. X sub 2n is about the size of alpha to the n, and x sub n is something a lot smaller. So here the dominating term is alpha to the n. Like this is basically k over alpha to the n. X sub 2n is also basically alpha to the n. So this thing will like... Wait, something's really wrong. I messed something up. So the sizes are not matching at all. Because this x sub 2n is very close to alpha to the n. So this fraction is almost just 1. And now there's this really big thing floating around. So something's wrong. Alright, let's backtrack. Boom, boom, boom. -1, -2, +1, minus epsilon to the... Oh shit, this is a plus sign. Or something. Okay, let me fix this. There's no 2s. Okay, wow, life just became a lot easier. Jesus, okay. There's no -2 here either. Oh, that was stupid. Okay, so this thing goes away. This goes away. This 4 that I drew out of nowhere goes away. Yeah, and then this minus, yeah. Okay, 2x sub 2n. So this thing is very close to 0. This is a minus k. This is very close to 1. We are trying to get k equals 3. Epsilons are... In general, every epsilon is really close to 1. So it's like 2 equals... 2 plus epsilon equals minus... Okay, I flipped another sign somewhere. What did I mess up? What did I mess up? Oh, minus here. Okay. Oh, but that's not good then, because then this doesn't tell me anything, right? Like, it... Yeah, this doesn't give me any new information. Like, I know this is like... Okay, actually, but here. Alright, here. This thing is close to 0. So I'm just gonna write like... So alpha to the n and x to the 2n. Like x sub 2n is a lot bigger, because it's... No, wait, what? Well, okay, well, the point is this is less than like k over 2 alpha to the... Which did I get the sign right? One of these is bigger. Alpha to the n. Is larger. Yeah, so this is the way I want it to go. And then once I get here... Like, the point is, this is bounded by a constant, right? Like, this whole thing is bounded by a constant. So this is, yeah, this whole right-hand side is bounded by a constant, because this is up to 2k-ish. Bam, and then here. So in order for these to match, these two things have to actually be equal by taking n, because this whole... This entire blob... I'll write it like this. This entire offset is bounded above by some function of k. Okay, I think this is the foothold I need. So, like, because this 1 minus epsilon, I actually need this. I thought I could just treat this as, like, almost 0, but I actually need a little more care. I need to say this thing times x sub 2n is... Wait, what? Did I flip a sign? Shit, did I flip a sign? Oh no. Well, okay, actually it doesn't matter. I'll just drop the factor of 2. Ha. So this whole thing is bounded by like... $2K... Yeah, the whole thing is bounded by like less than 2K. And then meanwhile, this thing is minus K plus epsilon 2n. And squares get farther and farther apart over time. So like for a sufficiently large n, these two error terms have to actually match. But we actually have very good control over the error term because we have an explicit expression for this. So that means I can set these two error terms equal, and it will tell me what? As the squares get farther apart, the error terms must coincide. So for large enough n, we need to identify... So 2 times 1 minus epsilon n, which, as I said, so this is sort of the main term. It's like... And then the other two terms are like... whatever the hell they are. So every epsilon is 1 minus O of alpha to the minus n. We're gonna throw away that extra precision now, because I don't care about the little pieces. So this is O of alpha to the minus 2n. Well, actually, I'm just gonna write little O1. I don't even care what it is. Is that bad? I think little O of 1 is fine, right? This is like... So this epsilon 2n is also 1 minus little O of 1. Plus little O of 1. This is k, k. And this thing here, it will be like very, very close to 1/2. I got swindled. Something's wrong. Okay, let me not we think k is supposed to be equal to 3, right? So this is like 3 minus 1 over 1/2. Oh, I dropped the factor of 2. That's why. Okay. Wait. What? No. Stop. No! Oh, this doesn't tell me anything new. Because this is close to 1. And this is also close to 1. Really? This doesn't tell me anything? I finally got the error terms to line up. Lame. Ah. Shiba. Hmm. Shiba. Shiba. Yeah, I feel like I don't know. Can I pump? Like, is there more info to pump out? Like, I feel like wasn't expecting. I feel like this was supposed to give me the same thing I already had. Yeah, I think it all basically does, right? Like, if I take 1 minus epsilon n and I plug in this thing, it's not quite nothing, but it's like pretty much nothing, right? Like this thing is just about as, like this thing is very close to this, and like unless I'm like comparing the error, like I that's like sand. That's like grains of sand level of precision. Like I don't know if I can. Like epsilon n is like one. Epsilon n is like basically one, I guess. Like. But the issue is that it's not so close to this. This term doesn't vanish. This term is it's pretty much k over 2 x up to n, right? Like it's like this is pretty much this, or like k minus 1 over that. Like I don't know. Like, do you want me to do the surgery? Like, with like analyzing the really tiny error term. I mean, I'm like maybe it'll work. I can't really tell. But it seems like really precise. Alpha to the n minus epsilon n is always an integer. I mean, yes, that is true. I don't see why that does anything though. Like it. Do you teach on remaining days? I only stream on Fridays now, basically. Like I run Otis, which is like an Olympia training program, but that's not meeting based. That's more That's all in sync. Epsilon n is roughly c over alpha to the n. Wait, what? No, that's false. Epsilon n is close to 1. You want 1 minus epsilon n? Yeah, but we have that, right? Like, this equation says 1 minus epsilon n is basically 1 over 2 alpha to the n. Like, we have this. I just don't see why that helps, right? Like, if you use that bound here, like, you know, great, this is basically k, and this is basically k minus 1, which is what we expected. Like, I can try to be more careful with the estimate, but it's gonna be really nasty, right? Like the level of precision that you would need to, like, it's like you want, like, if you want me to use this thing, like, you're basically asking me to, like, show that alpha is an algebra. What? Okay, now I have no idea what's going on. What? You show alpha's algebraic with inequalities? That's gotta be a first. The frick? How do you prove a number is algebraic with inequalities? That's a thing you could do? Like, what? I... Unless you're telling me that I'm not supposed to be using inequalities. Ah, Shiba. Okay, I thought no, but no, come on. There's still an epsilon 2 in here. Like, I think. There's an epsilon 2n. Like, there's a freaking epsilon 2n. You can't get rid of that thing. Like, okay. If you want me to show it's algebraic, that means I'm not using the inequality anymore, right? So what you're trying to get me to do is you're telling me that I want inequalities mod 1? I have no idea what that means. I mean, like okay, and then like, but this is still. I don't. No, you can't. Like, unless you have like some. Okay, if you just have a generic real number alpha, can you like say anything about the size of the fractional part of alpha to the n? Alpha, what? Like, I don't... The frick is this? K minus 1 plus O of alpha to the minus n. Alpha to the n. Well, I mean, it's just like you. I don't understand how you can like prove an inequality. Like doesn't you can't prove a number is algebraic using inequalities. That's just not. Hey, what? What on freak? Okay, x sub 2n is alpha to the n plus like some very very small error. 2 alpha, like alpha to the n plus like O of alpha to the minus n-ish. Alright, my k is fixed. So you're like telling me that like thank you Atomi2 for the follow. Can you what? Like no, I understand that you have these bounds, but like I don't see how that's ever going to give you like. Well, I agree you get bounds, but I don't understand how you can like take an inequality and use that to conclude like. Equals like that a number is algebraic. Like I. You have an exponentially decaying error term. What? Oh. You want me to square both sides of this and then compare it with the corresponding equation for 4n. Or not even just like, oh god. Okay, that's not showing alpha as algebraic, but I think okay, but but the errors are so... Right? Sorry, this should be alpha to minus n. Oh wait, there? No, that's not good. Like k minus 1 over 2. Like this is a thing. Okay, so I'm gonna drop the... The Actually, wait, can I just forget squaring it, can I just put this thing back in here? And it's like alpha to the 2n, this, it's like... Oh god, if I square it... Okay, so all the error terms are... Okay, fuck. Dude, I don't know how you... Whatever, we're just gonna square it. I'm gonna take this thingamablobber and epsilon is like, oh yeah, okay, fine. I just throw it back in here, right? And the point is I take... This requires a bit of care. Okay, so I'm going to actually write what this is though. I'm going to write this as k times O of alpha to the minus n. This should be a true statement. So x sub 2n equal to this, which is alpha to the n plus frac k minus 1 over 2 alpha to the n. Oh god, I have to be so careful. Plus O of like alpha to the minus 3n, and then is that like, okay, how do Taylor approximations work? It's like, oh god, dude, I'm not an analyst. Okay, this is too. Can I just drop all the... Will anyone get mad at me if I drop the k's? Does that matter? If I treat k as an absolute constant, I don't know. It gives me a little bit of the heebie-jeebies, but I think it's okay if I consider k as constant and wrap it in the big O. Because otherwise I feel like this k times stuff is actually really annoying. I think that shouldn't matter. If I just treat the... Okay, I think this is a true statement, alright? I think this is k minus 1 over 2 on the top, alpha to the n on the bottom, and then plus an error term that's order of alpha to the minus 2n. I think that should be true. Right. Yeah, I think that's fine. Okay, and now we square both sides. So x to the 2n squared is equal to alpha to the 2n plus k minus 1 over 2 squared times alpha to the 2n. And then the error that I get is up to alpha, O of alpha to the minus n. However, this is also equal to alpha to the 2n minus k plus this epsilon 2n, which we agreed is 1 minus O of alpha to the minus 2n. Okay. And also I fucked up and I dropped a term. Oh, there's a missing k minus 1 here. And I have messed up some other term. This is plus, minus. Shit, no, I got the same thing again. Ah, no. No, it's still k minus. Oh lord. I hate this. So close yet so far. Okay. Yeah, no, because the problem is this error term is all the way up to alpha to the minus 2n. Right, so this error term here is like all the order of minus 2n. So I can't just like get this 2n part to... It just doesn't match. Jesus Christ. I don't. Oh. I didn't mess up, right? Like this is the error term analysis. Like this error term is as large as, like, unless, no, I can't get more precise than that. Actually, okay, I can be more. Oh, I. Oh no, it's gonna, like, if I have to actually drill each of these terms in, then that's really rough. This being an integer. I don't like I don't understand what that's gonna do for you, right? Like, this thing, this error is alpha to the minus 2n. So, like, you're trying to say, like, okay, like, this is close to it. Like, like, this is not how numbers work. I should be looking at this line. You want, okay, so these are two numbers whose product is what is this rational number k minus 1/2. I don't even know it's an integer. It's a half integer, I guess. It's half an integer. And their sum approaches an integer. I don't know what that's supposed to do though. Like I what? Like, okay, I see that the product is k minus 1/2, and then I see that their sum is, like, very close to it. It's like within alpha to the minus 2n or of an integer. I don't like this. I don't see how this tells you that it's an algebraic. What? Dude, 2 hours ago you told me this problem was not that bad. No, I mean, this is all fine, but it's like, I don't, like, am I insane? Like, you can't, like, close to an integer doesn't get you algebra. The yeah, I see it. That sounds so. What on earth? I mean, okay, sure. Um, yeah, I mean, okay, so when I multiply that thing, and I mean, okay, so this is like, I mean, you get two terms, right? It's like x sub 2n plus 2, that's x sub 2n minus 2, and then plus like a bunch of error terms. Well, we're gonna treat alpha as a constant too, so it just gets swallowed up. So like, okay, like, yeah, but like the problem is like this is still integer, fine. So like what? Do I treat this as like, oh look, there's a linear recurrence with an error, and then like hope the error doesn't accumulate? I guess the error grows pretty slowly. Um, Compared to, because this alpha to the n is a lot bigger than this minus 2n. So what you can do is you can say, because I don't think integer helps you if you don't know alpha plus 1 alpha is an integer. This doesn't. Is that? No, they can't. You can't say anything about the fractional part just based on the size of the number. Yeah, I mean, I do agree. Like, it seems like what this suggests is that this suggests like x of 2 n plus 2 should be very close to like, well, actually no, that doesn't even, it tells you that it's like, what do we show the error is just 0? Like, this thing is not a priori an integer. The x of 2n grows very quickly, and so move all the integers. What? But like alpha plus 1 alpha is not an integer. Like this thing is not a priori an integer. So you can't like. Am I being swindled? Yeah, so, okay, like, x of 2n plus 2 plus x of 2n minus 2, so x of 2n, and x of 2n grows on the order of, like, alpha to the n. So this is like, it's like alpha plus 1 alpha plus like O of alpha to the minus 3n or something? Like sure, but like now you have this like rational thing, right? Like it's not as if a sequence of rational numbers that has a limit has a rational limit. Like this is not how real numbers work. But you're not gonna you can't. Okay, let me move some of this stuff because I'm running out of space. Yeah, like I know the right hand side is rational, but I don't see how that helps. Like what's the magnitude of the difference of two rationals? What? Oh, is that how it's gonna work? You can't approximate this well enough. The error term is alpha to the minus 3n, but the rationals have to... Because x of 2n is about alpha to the n, any rationals have to differ by at least alpha of the minus 2n. So I subtract two adjacent things. Oh, what the fuck? Okay. And here you told me this problem's not that bad, and I need to like approximate rational. Okay, I agree that the error term drops because the rationals have denominator on the order of alpha to the n. So the difference of two of them has denominator on the order of alpha to the 2n. So in fact, all the error terms have to be equal, and since the error terms also decay, they have to be 0. So use the denominator argument. Okay. See, I'm still mad, because you were telling me to take mod 1. This is not taking mod 1. This is like... The integers are not big. Like, there's a difference. Like, you have to actually... Okay, anyways. I agree this works. But it's not what you were suggesting. Anyways. So I have to conclude the error terms between consecutive and match. And hence vanish. So Okay. What the hell? Okay, and now because it's an integer sequence, bona fide linear recurrence, and we have exact equalities. 2n equals alpha to the n plus alpha to the minus n. Yeah, I mean, JMO45 didn't take the... JMO5 took a little bit of time. It's mostly this thing. This is taking all night. Like, it's a good problem. I'm glad I'm finally doing it. But also, like, what the heck is this? For some constants, lambda plus and lambda minus. But from our explicit form. So then these constants have to match this one. It has to be this thing and this thing. Exactly, because otherwise this error term is, you know, alpha to the minus 2n. So, but actually lambda plus, yeah, okay, now we're over the hurdle. So now we know exactly what it is. X up to n is exactly given by alpha to the n. The error term goes away. The error term dies, and then I'm gonna have a lot of fun writing this up. I may have underestimated this problem's difficulty. Yeah, after like dragging me through this, kicking and screaming for the last 2 hours, it's like, oh, yeah, it's not that bad. It's very nice though. Yeah, that part I agree with. Anyways, okay. I need to actually finish this up. Alpha to the n. K minus 1. Yeah, I still don't have k equals 3 yet, but I have a structure recurrence. Yes, I want this to be 1. How do I do that? Can I just do that? Like now I can square both sides, right? Because you get like this k minus 1 over 2, and that k minus 1 over 2 has to equal 1. If you were in grade 9, how much time would it took to solve for you? This problem, I don't think at 9th grade everyone solves it. I don't know my analysis well enough in 9th grade to even get close. Yeah, I'm gonna write up a solution to this. Also, oh my lord. It is actually square both sides after this, right? Like, because x up to n, well, I guess x up 4n, but... Yeah, that should work at that point. Yeah, like definitely the part it's this size of denominator thing is like the it works. I agree. But it's like you're not just using that they're integers. You're using that they're integers for which you actually have a good estimate on how big the integer is. Everything before... I agree everything before this is not unreasonable. Like, I can get behind the part before this. It's like, okay, like, you know... given that the answer turns out to only be k equals 3, like, you have to do something like this. But I mean, once you have this, you're fine, right? Like, you literally have the linear. Anyway, okay. Wow, what a problem. All right, this is gonna be fun to write up. I'm so excited to find out which person proposed this. Well, does Brazil tell us who the author is? Is this like a Carlos? I don't know. Does Carlos make up stuff like this? Ah, yes, the bacteria question. 59 seconds for the rest of the audience. I am going to sleep after this. Alright, yeah, let me write this properly. Okay, epsilon n equals 1 minus... Okay, note that. We'll quantify this as 2 alpha to the n plus O of alpha to the minus n. Oh, actually, I don't need to annotate this here because I annotate it later. So I guess technically I could have been like a little more careful here, but I don't think it really matters. Yeah, it shouldn't matter from what follows. Did I do this with bound calculation right? So 1, 2 off to the end, what's off to minus n? Yeah, that's all fine. So okay, in this whole blob, I don't do I need the I do, right? I actually need the which we manipulate to wait, where'd the alpha? I just spent the start of the stream giving an advertisement for types for the people who can't figure out how to learn LaTeX, which apparently is a lot of people. If anyone wants to drop that link. Yeah, I mean, pen and paper is fine too, just not digital, you know, but you do you. It's not a big deal. claim the above equation holds even is true. Suppose we wrote yn define equals I don't know how to write this, honestly. I actually haven't seen an argument quite like this before. Or at least not recently. I've probably seen something like this somewhere before, but not of. Is the difference of two terms which are O of alpha to the minus 3n. However, it's the difference of two rational numbers whose denominators are each O of alpha to the n, ergo their difference is at most each difference at most of. Must be eventually 0. Wow, what this is an argument of all time. Wow. Thank you, Oatmeal, for the follow. What is the Python what? This, we have a bona fide linear recurrence with exact inequalities. Alright, I'm actually going to use equation environments even though they won't show up in LaTeX. I actually think I need them to make this sensical. Actually, maybe I don't need to label them. Plus yeah, okay. What field is your PhD in? Automorphic forms, number theory. Not that I have any idea what those things are. Wait, why didn't this... minus 2n. Yeah, now I just compare. Right? Wait a minute. What? No, this isn't... Wait, hang on. Now I'm confused. Wait. Hang on. Wait, how did the finish work? Wow, this problem just won't die. Wait, how did I... I have passed my qualifying exams and then spent a long time not understanding a bunch of papers that I was trying to read. If you want to follow along the what I'm trying to do, there is a website that I can show you, and you can see just how little I've managed to accomplish. Are x2n and xn... Oh, good point. Okay. On the other hand, we are supposed to have... See, it's funny because I have to actually use 2n and 4n, right? In order for this to work. Forces k equals 3. Wow, what a problem. Oh my god. Oh. Yeah, alright. What a problem. What is it like to be this smart? You're giving me a little too much credit. Alright, well, that was... Let's link it to my notebook. Alright, where was I? Alright, we're gonna post up this monstrosity that we came up with. I actually don't know what to tag this other than like we used a ton of analysis. Oh, fine, hard answer. Yeah, that's pretty good. Yeah. I don't know why there's a dot, comma dot here. All right. Well, hope that was an experience. Yeah, we need more problems like this. This is what Olympiad number theory should be like, except maybe not quite this hard. Because wow. Well, I don't know. I mean, if people can get a problem like this in 4.5 hours, all the power to them. I don't think I could. Alright, cool. For those of you watching on YouTube, I'll probably cut around here. Thanks for tuning in. Yeah. See you next time.